For as long as humans have looked toward the stars, one question has echoed through every generation. Is Earth the only home life has ever known? For centuries, there was no way to test that idea. The stars appeared as distant points of light, and planets around them remained completely invisible. Even the most powerful telescopes could do little more than reveal their host stars. Today, that has changed. Modern astronomy has entered an era where scientists can study the atmospheres of planets hundreds of trillions of kilometers away, not by traveling to them, but by analyzing the light that passes through their skies. At the center of this revolution is the James Webb Space Telescope. Positioned nearly 1.5 million kilometers from Earth, Webb was designed to observe the universe in infrared light, allowing it to detect details that previous space telescopes could never see. Instead of simply discovering new planets, Webb can investigate what surrounds them. And one distant world has captured extraordinary scientific attention. Its name is K2-12B. Located about 120 light-years from Earth in the constellation Leo, K2-12B orbits a cool red dwarf star much smaller than our Sun. Although that distance is unimaginably vast, the planet has become one of the most carefully studied exoplanets ever discovered. The reason is simple. It may possess ingredients that scientists associate with potentially habitable environments. K2-12B belongs to a mysterious class of planets called sub-Neptunes. These worlds are larger than Earth but significantly smaller than Neptune. Curiously, our own solar system contains nothing quite like them. That makes them one of astronomy's biggest puzzles. Are they giant rocky planets wrapped in thick atmospheres? Are they miniature gas giants with no solid surface? Or could some hide enormous global oceans beneath layers of hydrogen? Astronomers are still searching for the answer. One reason K2-12B stands out is its location. The planet orbits within the habitable zone of its star, the region where temperatures could allow liquid water to exist if the atmospheric conditions are suitable. Being in the habitable zone does not automatically mean a planet supports life. Venus reminds us that atmosphere matters just as much as distance. Still, the discovery made K2-12B an excellent target for closer investigation. When the planet passes in front of its star, a tiny fraction of the starlight travels through its atmosphere before reaching Webb. Different gases absorb different colors of infrared light. By measuring those tiny changes, astronomers can identify which molecules are present. It is an astonishing technique. Scientists can determine the chemistry of a world they may never visit, using nothing more than light that has traveled across space for over 100 years. When Webb examined K2-12B, several important molecules appeared in the data. Researchers found evidence consistent with water vapor, methane, and carbon dioxide. Each of these compounds plays an important role in understanding planetary environments. Together, they suggest that K2-12B possesses a complex atmosphere rather than a simple cloud of hydrogen and helium. Then came the result that attracted headlines around the world. Researchers reported tentative evidence for a molecule called dimethyl sulfide, often shortened to DMS. On Earth, DMS is produced primarily by marine microorganisms. That immediately raised an exciting possibility. Could the same molecule on another planet indicate biological activity? The scientific community responded with both excitement and caution. A possible detection is not the same as a confirmed discovery. The signal remains weak, and additional observations are needed before researchers can determine whether DMS is truly present, or whether another molecule produced a similar spectral pattern. That distinction is critically important. Science advances through evidence, not assumptions. Extraordinary claims require extraordinary verification. Even so, K2-12B has already changed how scientists think about potentially habitable worlds. Not long ago, the search for life focused almost entirely on rocky planets that closely resembled Earth. Today, researchers are considering a much wider variety of environments. Some astronomers have proposed that K2-18b could belong to a new category known as a Hycean world. These hypothetical planets would possess hydrogen-rich atmospheres covering vast global oceans. If such environments exist, they could greatly expand the number of places where life might survive. Whether K2-18b truly fits that description remains under investigation. But one thing is already clear. This distant world has become one of the most important laboratories in humanity's search for life beyond Earth. Every new observation adds another piece to a puzzle that stretches across our galaxy. And perhaps, somewhere within those faint signals carried by ancient starlight, lies the first real clue that life is not unique to our own planet. Scientists found evidence for water vapor, methane, and carbon dioxide in its atmosphere. They also reported a tentative signal that could be consistent with dimethyl sulfide, or DMS, a molecule associated with biological activity on Earth. But before anyone can claim the discovery of alien life, an important question must be answered. How reliable are these observations? Unlike planets in our own solar system, K2-18b cannot be photographed in detail. It appears as a tiny point of light, completely overwhelmed by the brightness of its parent star. Instead, astronomers rely on one of the most remarkable techniques in modern science. As the planet crosses in front of its star, a minute fraction of the starlight passes through its atmosphere before reaching the James Webb Space Telescope. Different gases absorb specific wavelengths of light. By measuring those missing wavelengths with extraordinary precision, scientists can reconstruct the chemical composition of the atmosphere. It's like identifying invisible ink by observing which colors of light disappear. Yet the process is incredibly difficult. The signals are tiny. The star itself can introduce variations. Instrumental noise must be carefully removed. Even the smallest error can change how researchers interpret the data. That is why every exciting result must be tested repeatedly. When the possible DMS signal was announced, scientists around the world began examining the evidence. Some researchers considered the detection promising. Others suggested the same spectral features might be explained by different molecules or by limitations in the current observations. This is exactly how science progresses. New discoveries are challenged, analyzed, and tested again. Only after repeated observations produce the same result can confidence begin to grow. At the moment, there is no confirmed evidence that life exists on K2-18b. The planet remains one of the best candidates for future investigation, but the case is still open. Even if DMS is eventually confirmed, another mystery remains. Could nature produce it without life? On Earth, nearly all known DMS comes from microscopic marine organisms. However, K2-18b is not Earth. Its atmosphere is dominated by hydrogen. Its gravity is stronger. Its environment may be unlike anything in our solar system. Scientists must first determine whether unfamiliar chemical reactions could create similar molecules without biology. Until those questions are answered, caution remains essential. At the same time, K2-18b is transforming the search for life in another important way. For decades, researchers concentrated almost exclusively on planets that closely resembled Earth. Small, rocky, orbiting stars similar to the Sun. Today, that view is changing. If Hycean worlds truly exist, planets with deep global oceans beneath hydrogen-rich atmospheres, then the galaxy could contain many more potentially habitable environments than previously imagined. Instead of searching for one type of world, astronomers may need to investigate many different planetary environments. Some may resemble Earth. Others could be completely unfamiliar. Life, if it exists elsewhere, may have evolved under conditions very different from those on our own planet. The James Webb Space Telescope is only the beginning. Future observatories will carry even more advanced instruments capable of analyzing exoplanet atmospheres with greater precision. Ground-based telescopes now under construction will collect enormous amounts of light, allowing scientists to study distant planets in unprecedented detail. Together, these observatories may eventually detect multiple biosignatures at the same time, a combination of gases that cannot easily be explained by non-biological chemistry. That would represent one of the strongest pieces of evidence ever found for life beyond Earth. Whether K2-18b becomes that historic discovery remains unknown. But it has already achieved something remarkable. It has expanded humanity's imagination. A generation ago, planets around other stars were only theoretical. Today, we can estimate their temperatures, study their atmospheres, search for water, and investigate molecules linked to biology. What once belonged only to science fiction is rapidly becoming part of observational astronomy. Perhaps the greatest lesson from K2-18b is not that we have found alien life. It is that we finally possess the tools to begin asking the question scientifically. Every observation pushes the boundary a little farther. Every new spectrum reveals another clue. And every distant planet reminds us that our solar system is only one tiny corner of a galaxy filled with hundreds of billions of stars. Somewhere among them, another living world may already exist. Whether K2-18b is that world remains uncertain. But thanks to the James Webb Space Telescope, humanity has taken one more meaningful step toward answering one of the oldest questions ever asked. Are we alone? For the first time in history, that question is no longer guided only by imagination. It is being investigated with evidence, precision, and the most powerful space telescope ever built.